Good morning, geometry. Guess what? Section 19.3 today. So what we want to do today is continue dealing with three-dimensional objects. Today we're going to find the surface area of pyramids and the surface area of cones. All right? And we'll try to go this one slowly, just as usual, show some examples. All right, so we're on page 1005. And again, I took the time and did it in green, just like I would do it if we were in class. As we're looking at, they're showing here in the Explorer how to find the surface area of, in this case, they're using a regular pyramid. Again, here's a picture of a regular pyramid. And again, going back, we see that the base is a perfect square, and then these sides of the pyramid are isosceles triangles. All right. So what they did on the right hand side is they opened it up, they made a net of it, and then I'm just going to let you guys read this stuff because it leads up to the two formulas. But again, if you feel like you want to do it another way, all you got to do in this case is if we can find the surface area of this triangle, and in this case there are four sides, we just have to go 4 times one area of these sides plus the area at the bottom or the base of the pyramid. Okay, so that's pretty much what surface area is all about. Just think of it as how many square feet or square inches of wrapping paper is needed to wrap this pyramid. Okay, so that's all we're going to do is just do some examples. So here's what we'll do. At the top of page 1006, they give you the formula for the surface area of a pyramid. Again, they call this outer part or the top part of the pyramid. They call that the lateral area of the regular pyramid, and then down below is the base, is the bottom part of the pyramid. And once again, to figure this one out, the L represents lateral area. So lateral area equals 1/2 times the perimeter. In this case, they did this back here, the perimeter, times the slant height. That's this height right here. That's what they call it, a slant height. Okay. I'll let you guys figure that out. Okay, it's not that hard. It's just using two formulas. It's no big deal. You're gonna do absolutely fine. Okay. So down below here is in example 1. We're just going to focus on 1B. Okay. Here we have a regular pyramid here. It has a base of 10. Now this one's a little bit different because letter A, they gave us the slant height. What we got to do in this case is do this problem, we have to find the slant height here. All they did is gave the interior height. Okay. And they identified that this is a right triangle, so you can figure out what the lateral length is in this case by taking, again, using the Pythagorean theorem, and that's what they did here. Okay, so I'll let you guys follow that. So now to find the lateral area, we take 1/2 times the perimeter, which in this case there are 4 sides here. So 4 times 10 is 40, times your lateral, your slant height, which is 13, and we get 260 square meters. That is how much they're talking about the top part here. Now the next part down here is finding the total surface area. So the lateral area, once again, that's that outer part. Okay, actually the top part. Okay, so the next thing we do is want to find the total surface area. So you take the lateral area, which we already know is 260, plus the area of the base, which is a square. So it becomes 10 squared. So the total area to cover this entire pyramid would take 360 square meters. This is something simple. You guys will do fine on this. All right, now the next thing we did is I did the your turn. I did another example, and I set it up. Okay, ready? We want to find the surface area. So I I didn't do the lateral. Will be doing the lateral area, but the surface area is going to be 1/2 times the perimeter, which is the perimeter of the base, times L, which in this case is your slant height, plus the area of your base. So the first thing we got to do is, I set these already up. 1/2, P is 24 because we have 4 sides that are the same length. So there are 4 sides times 6 gives you 24. And now the L, which is the slant height, we have to go and do it over here. I did it on the side. So again, using the Pythagorean theorem, because this is a right triangle. So L squared has to equal 3 squared plus 8 squared. Now again, you're probably saying, where did I get the 3 squared? Well, the whole length down here is 6 feet. Half of that will give you 6. I'll give you 3. So all this right here tells me that the slant height is a square root of 73. So I put it there. Plus, in this case, the area of the base is 6 squared. All right, now the next thing I did is I just used my calculator. So I put 0.5 times 24 times the square root of 73 plus 6 squared. Again, I did everything on my calculator, plugged it in. There was nothing fancy here. I hit enter, and we get 138.53. They said round to the nearest tenth. I rounded to the nearest hundredth. It's no big deal. So 138.53 square feet, or cubic feet. Okay, why do I have cubic feet? It's square feet, okay, because we're dealing with area. All right, now the next one is finding the surface area of a cone. Now this one's a little bit different, okay? In the example 2A, which really should have been an Explorer, this part down here here is your net of your cone. So we got the bottom flicked out. You can figure out the area of the bottom part, or the base. That's pi r squared. Now over here, when you open this cone up, it's going to look something like this. Part of this is missing, okay? So what we got to do in this case is, in order to figure out what this area is, we have to use this information down here. So the area of sector, in other words, that's this part, that's the area of the sector divided by the area of the circle C. So in other words, here's your whole circle. The area of the sector is the gray part, okay? So, and to do that down here, to find the area of C, okay, of circle C, it's the circumference of C. All right. So again, this is something we probably talked about in previous chapters. Okay. So this, again, you guys can follow this, but if you just go over here, I'll let you copy that. But if you go over here to the formula, this is all you need to know. Okay. Surface area, again, this right here is this area of the cone, okay, which is the lateral area of the cone, which is pi times r times L, which again, we may have to find L, okay? And this part right here is the area of the base, all right? So, now what I did is I did 2 more examples just to help you. So I'll let you fill that in. Pause your video. I'll just work it up. I got to set up here. All right, first things first is this is all they gave us. They told us that interior height is 24 centimeters. The length of the side of this cone is 25 centimeters, and they don't give us the radius. Well, we need that for the formula. So the first thing we do is we have to use the Pythagorean theorem. Again, the hypotenuse squared must equal the square of this plus the square of this. Okay, so that's what they did here. Found out that the radius is 7. And then now to find the lateral area, it's pi times your radius times your slant length, which is 25. And they got 175 pi centimeters. Now again, they're going to probably throw a lot of these answers out like this. Sometimes they'll say, we're just going to leave our answers in pi form. So again, you can leave your answers in pi form. unless you see they have decimals in your solutions manual. All right, so the surface area is taking the lateral area plus the area of the base, which is pi r squared, and we get 224 pi centimeters squared. So this right here is your surface area. So now they're asking you how much paper, plastic will you need. Again, all they did in this case is they took all this top part and they just put it into a decimal form. I'll let you guys follow that. All right, so let's wrap it up with this last one. All righty. Here we have a cone. We see that the interior height is 4 inches, and they gave us a diameter of 6 inches, and this right here is your slant length. All right, here's our formula. So again, our surface area is the lateral area, which is pi times radius, times the slant length, plus the area of the base, which is pi r squared. Well, again, I filled everything, but we defined that you got to go down here. We know that our radius is 3 because the diameter is 6, so we can do a radius of 3. Again, a squared plus b squared has got to equal L squared. And we got L to be 5. And all we did is plug everything in. Now again, what I did here in this case is I left my answer as a decimal. So didn't leave it as in a form of pi. So here I'll show you what I did. Did second pi, or second shift, times 3 times 5 plus second shift. You know what, I did it in parts. Let's just keep it to what I had here. I did it in parts. So second, we need pi, times 3 times 5. That's where I got 47.1. I round to the nearest tenth. Then we go pi times 3 squared, which is 9. We get 28.3, around to the nearest tenth. So 47.1 plus 28.3, and we get 75.4 square inches is the surface area. So that is what section 19-3 is all about. It's really not that difficult. The only tricky thing that you're going to run across is getting over here to mostly with cones, I believe. Now again, I am not showing any examples of composite figures, because those, I'll let you guys figure that out. So you'll have no problem. Again, if I was to show you, again, if we're dealing with the surface area, again, we would have to find the area of, in this case, for this problem right here, all we need to do is find the lateral area and then the lateral area of this prism and the area of the base. So this one requires finding 3 different surface areas. A lateral area, plus area of the base. I'll let you guys handle that. That's pretty much it, guys. That's section 19-3. Catch you on the next one. Bye.